there's your thought for the day. We're going to cover 6.2, similar triangles. Our objective is to define similar triangles and use triangle similarity shortcuts. What does it mean for geometric shapes to be similar?
Same shape but not the same size.
Right. They're the same shape. They're not necessarily the same size. What two geometric shapes always have similarity? Yes.
Square?
One of them is a square. What's another one? Anybody know? Zach?
Rhombus.
Nope. Lily? Circle. Square and circle. Triangles are not always similar. For example, you can have a right triangle and an equilateral triangle. But we can use them to find measurements indirectly without measuring the distance. Definition of similar triangles. If triangle ABC is similar to triangle DEF, and the correspondence A corresponds to D, B to E, C to F, if and only if all three pairs of corresponding sides are angles are congruent. So all three angles are congruent, all pairs of corresponding sides are proportional. Right? So that's described down below. That means that the ratio of A to B, it corresponds to DE in the second triangle. So the ratio of AB to DE will be the same ratio as BC to EF and AC to DF. That would show they're proportional. So three angles congruent, all three sides proportional is by definition. The following relationships hold for similarity: the reflexive property, symmetric property, and transitive property. Reflexive, it equals itself. Symmetric, you switch the order. Transitive, if triangle ABC is similar to triangle DEF, and triangle DEF is similar to triangle GHI, then triangle ABC is similar to triangle GHI. I'm going to add another one to this list. For, we're going to say, in similar triangles, any corresponding parts are proportional. This doesn't just include sides, it includes altitudes, medians, and angle bisectors. All right, any questions there? Okay. 6.8. All pairs of triangles in the figure 6.3 that satisfy the definition of similar triangles. Identify other pairs that appear to be similar. Okay, so according to our definition, all three sides have to be congruent, and all the pairs of sides have to be proportional. Take a few minutes and identify the triangles in here that are proportional by meeting that requirement, and then which ones appear to be, but we don't have enough information. I'll give you a few minutes to look at that. You'll have to sort of test out some ratios and stuff like that to see if it works. All right. Which two triangles are similar? There are only two that we could prove were similar. Shatice?
I'll name one of them BCA and KJL.
Yes. Okay. We could do triangle BCA is similar to triangle KJL. He got the letters corresponding correctly. We know that because in BCA, angle B is congruent to angle K. Angle C is congruent to angle J. And angle A is congruent to angle L. Right? All three angles are congruent. And then so if we were proving this, we'd have to write that out. Angle A is congruent to angle C, angle L. Angle B is congruent to angle K, and angle C is congruent to angle J. So the angles are matched up. Then we got to match up the sides. The shortest side of BCA is 4. So 4 would match up with the shorter side of that other triangle. 4 would go with 8. And that's 1/2. 6 goes with 12. That's 1/2. And 8 goes with 16. That's 1/2. 8 goes with 16. They all have the ratio of 1 to 2. They all equal 1/2. So, there we have the triangles are similar. Now, what others appear to be similar? Give me a pair that appear to be similar, but we don't have enough information. Nina. Yes, triangle GHI appears to be similar to triangle MNO because they have 2 pairs of sides congruent and an included angle congruent. They both have an 85-degree angle, and then their side ratios are 2 to 1, except we don't know the third. There's 2 more. Someone give me another one. Somebody different. Anybody see another one? Zach.
Triangle QPR and triangle
QPR and what?
KJL.
QPR, KJL. Yeah, from the angles. Okay. So that would be a pair. I didn't have that one listed, but we could say that. So triangle QPR is possibly similar to triangle KJL because they have angles that are the same. Any others? Steez?
QRP and BAC.
Yeah, QRP. Triangle QRP is similar to triangle BAC, possibly, because of the angles. Okay, we'll stop there. I think you've got the idea. We need to move on. Okay. So, now we had, just like with congruence, how we have shortcuts, we've got shortcuts with similarity. Angle, 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 similarity. If all 3 angles are the same in the 2 triangles, then we can say they are similar. Are the following triangles similar by angle, angle, angle? What do you think? Shelby?
Yes,
Why?
because both of the triangles have the same degrees for the angles.
Well, I see 2 matching up. What about the third?
Well, you have to know that it's the same thing because both of them have the same degrees, so they
Right.
both be the same.
Right. Triangle sum says that would have to be 70. So we could say yes, all 3 angles congruent. Now, just because of what Shelby said, like she said, if we know 2 are the same, we know the third's going to be the same, so we don't have to prove angle, angle, angle. We can just do angle. We just need angle, angle. All you need is 2 angles to say the triangles are similar. If 2 angles are the same, the triangles are similar. Angle, angle, similarity. Okay, so let's apply this here. Triangle ABC, in that triangle DE is parallel to AC. AB is 6. CE is 1. AC is 8. BE is X. BD is 4. we have to find DE and BC. All right. So, first of all, what do we have to establish? Shatiz,
That they're similar.
how can we do that?
And we know that angle B is congruent to both of them since they both contain it.
Okay. What else? The lines are parallel, that should tell you. D is parallel to AC. What do we know from that, Shri?
They both are parallel, so equal BE will be congruent to BAC.
Yeah. Okay, we've got corresponding angles. This angle is the same as that because those lines are parallel, and this angle is the same as that because the lines are parallel. All right, so let's find DE. For DE, we would have, okay, somebody set up the proportion that we could find DE. How would we set it up? Shatice.
Like I'm using it like this way. So 6 to 4 equals 8 to x.
Right. Okay. You could. Okay. So the short side, the side, this 6 is to 4. As this side 8 is to DE. We'd cross multiply. We get 6 DE equals 32. So DE equals 32 over 6, or 16 over 3. Everybody have it? Okay. Let's find BE. How are we going to find BE? Adhicha.
X over 4 equals x plus 1 over 6.
Good. X is to 4 as x plus 1 is to 6. So we're going to get 6x equals 4 times x plus 1. 6x equals 4x plus 4. So 2x equals 4. So x equals 2, which equals BE. So then BC, which is what we have to find, equals BE plus EC. And we figure that out, so that'd be 2 plus 1. So it equals to 3. Questions? I haven't. Okay. Side angle side similarity. So we have two pairs of sides proportional, and the included angle, that's the angle between the two sides, is congruent. Then we can say the triangles are similar. So they're asking if these two are similar. So how? Okay, so we say we would have, here we have angle G is congruent to angle M, right? And then we've got 8 over 4 equals 4 over 2. That's true, so it's yes. by side angle side. (610) in the figure, AB is 7, BC is 10, AC is 14. If DB equals 5 and B equals 3.5, we have to state which two triangles are similar and find ED. So what they've done, here, what they've got is, both triangles have angle B is congruent, right? And you can see that where they redrew them. Then we've got the two triangles there with the given information. We have to find ED. All right. So we've got to test the side ratios. So what's the 7 going to correspond to? What number? 7 is to what? 3? 3.5, yeah. The 7 goes to 3.5, and that's the same ratio as 10 over 5. They both have a ratio of 2, and then they have the occluded angle. So the two triangles, triangle ABC, be careful how you name them. They're similar to triangle EBD by side angle side. Okay. So now how are we going to find ED? Somebody tell me how to set that up. How would I find ED? Emma, how would I find ED?
Could you use the 1/2 ratio?
1/2 ratio equals what?
1 over, or x over 14.
Yeah, equals ED over 14. The 1/2 came from here, right? So then we cross multiply, we get 70 equals 10 ED. So ED equals 7. Questions? Everybody has it? Okay. Side, side, side similarity. Two triangles are similar if 3 sides of one triangle are proportional to 3 sides of another. So we don't need to know anything about the angles. We just have to know that the sides have the same ratios, the corresponding sides for side, side, side. So in this one, we would test it. We'd take are these DF and STU similar? Okay, so we'd have 3 over 6 is equal to 5 over 10 is equal to 4 over 8. That's true. They all equal 1/2. They all have the same ratio. So we could say yes, these triangles are similar by side, side, side. Questions? No questions. Okay, that's it.